Hello guys, welcome back to my channel. So today I will be solving a very interesting problem from the CodeChef July Long Challenge Division 2. It's called ADA King, or you may also pronounce it as Ada King. So what this problem statement says, let's look into it. Chef Ada is training her calculation skills. She wants to place a king and some obstacles in the chessboard, such as the number of distinct cells the king can reach is exactly k. So here is one link given, also you can check it out, or if you have ever played the chess you can also understand that the king moves in all the direction only one cells. Like if suppose a king is present in one cell, it can go up to one cell in each direction, in eight direction, like four corners and four upwards, downwards, right and left. So it can go eight directions. So now what we have to do is we have to place some obstacles in the chessboard such that the king can exactly go to k distinct cells. So let's read through the problem. Recall the chessboard is consisting of 8 rows numbered from 1 through n 1 through 8, and 8 columns number 1 through 8. So let's denote row R and column C. So it's okay. So now here is what I just said, like the king can move only in 8 directions. So those 8 directions are like it says a king can move in any adjacent cell which shares a side or corner. So it which exactly means is king can move upward, downward, left or right, which means it should share a common side with the cell or a common corner, which means four corners. So this is exactly what is written over here. So simplifying this paragraph is what the king can move in total 8 directions, and the cell is denoted as x comma y. And let's see the input format over here. So the input format is first line is obviously the number of test cases, and then the only line in each test case is given integer k. Okay, so given integer k means the k amount of distinct cells which the king can travel, and output is print 8 line describing the chessboard's position or state, where we have to place the 0, which denotes the present location of the king, x, which contains the obstacles, and this dot, which means is empty. So we have to consist the chessboard in such a way where king can only move in k amount of distinct cells. Okay, so the constants are given, like t is can be the test case can go up to 64, and the k value is up to 64, because obviously it's an 8 cross 8 board. So the maximum amount of places the maximum amount of distinct places the k can the king can move up to is obviously 64. Okay, so that is given over here. And let's see and go through some examples. So here the 4 is the number of test cases, and let's see in the first test case it's given 1. So here we can see in the output the king is placed over here, and all the places surrounding it, there are x or obstacles present in 8 direction, upwards, downwards, left and right, and all the four corners. So king can not go anywhere. So king can only be present in its own location. So that's why it can only go up to one distinct location, which is currently its own location. So now for 5. So for 5, the king should be placed like something like this, where it can go one step upwards, one step this diagonally, so 2 steps, and total 2 steps on the left side also. So total 4 steps and its current position. So 5 distinct cells it can travel, and all other places are over here blocked using this x, and all these are empty cells. It cannot go through this x, so that's why it can go only up to 5 places. So this is a problem where we have to understand one thing, like this is not the only orientation where the king can only go to 5 places. There can be some other orientations also. So we have to find out that trick to solve this problem. So same thing here for 9 also. Here we can see it can go up to 9 places, and here there is no obstacle because the given value is 64. That means what, it can go anywhere in the grid. So 8 into 8, 64. So this is the problem statement, and let's see how we can solve it. So over here you can see I have drawn an 8 cross 8 chessboard over here. So let's see. As we have seen from the problem statement, we have to place exactly one king in the chessboard such a way it can go up to only k distinct positions. K distinct positions. Okay. So let's see. If we place one king over here, let's say we are denoting the king using the blue color. Okay. So let's see. We place the king in the middle. Okay. So we place it here, and so we have to place some obstacles over here. So let's say first the given k value is 1. So it means what? In the first test case, as we have seen, it can go up to only x test k, it can go only up to k distinct positions. So k is over here 1. So we have to block every other location where it can possibly go. So for it to go to only one distinct location, we have to block its all 8 directions. So first I am blocking the right, then I'm blocking the left, I'm blocking the upwards, downwards. So these are the 4 sides. It's so these 4 sides are blocked, but still it can go here, here, or here, or here. So we have to block these also. So let's just block them one by one. So this is blocked, this is blocked, this is blocked, and this is also blocked. So it can only go to one. But one thing to notice over here is, let's say the k now given is somewhat like 5. So is it possible for us to like do all the permutation and combination and check if, let's say, we are blocking here, so let's say it can move to here and here, then we block here, so it will be a rigorous task, right? So we have to find one way such that it will be a generalized method and we can do this for each and every test case. So let's see what the logic is. Okay, so the question says that we have to place a king no matter where. We just have to make sure that it can only move up to k distinct cells. So let's say first we place the king in the 00 location, which is this cell. We first place the king over here. So this is the location of the king. So now whatever the k value is given, let's say it is 5. So what we will do is we will just leave 5 spaces over here. 1, 2, 3, 4, 5, and rest of the places we will block, like here, 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 and so on. So if we do something like this, then just notice one thing: there is no option for the king to move anywhere else. So there is only 5 options there. So rather it will be 4 actually, because its own cell is also counted. So there is only its own cell and extra 4, so 5 options. So the king can only move up to 5. So our answer will be always like this, no matter what k is given. So let's say today our k is given as 10. So what we will do, is exactly, so let's just delete the crosses and let's try what we will do. So if let's say k is now 10, so then we have to put 9 spaces, right? So we will do what? Regarding we already considered its own location, which is this one, and we have to put 9 other spaces. So we put 1, 2, 3, 4, 5, 6, 7, 8, and 9, and we put rest of the spaces as blocked or obstacles, like this: cross, 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 and so on. We put everywhere cross, so that the king cannot move anywhere else except all those 10 places. So our task will be done. So this is the simple logic, which is at first a bit tricky to understand, but once you get the understanding of this logic, this is very simple. Like, they are asking us to make the chessboard such as that the king can only move up to k distinct positions. So they are not limiting us to put like a certain number of obstacles. We can put as many obstacles as we want. So this is the easiest way to think, that we can put every cell in obstacle and only leave those many cells where the k is allowed to move. So we put dot over here and we block all the other cells. So this is how our algorithm will lie out. And let's see again a recap of the algorithm and the steps of coding it. So let me go through this. So steps of the solution. So first step, first place the king in the 0 0 position. So 0 0 position is, if this is the board, then we have to place it over here. Then this one is done. Then at the second step, what is the second step? Leave gap of the amount of space which is required. So let's say with the k is 5, so 5 minus 1, that is 4. 4 amount of spaces needs to be left over here. Then the last step is fill all other locations as NA, or in the problem as it said, with cross. Filled it, cross. So these are the three simple steps which we need to follow for solving this exact problem. So let's go to the solution and code editor and let's code it out.
Let's go through the code of the logic which I have just mentioned. So over here we can see, first of all we are taking the input, and so we are taking the input as n, so which is mentioned in the problem as k. Then we are initializing an 8 cross 8 matrix or 8 cross 8 grid with all x. If we are initializing it with x, so then we don't need to explicitly put x, we just have to put the dot and this o, which denotes the king, and the dot denotes the empty spaces which we have to leave for the king to move. So we will be simply doing two for loops, and we will be checking if suppose I is equal to 0 and j is equal to 0, which means that we are at the first index where we are explicitly putting the king here. Answer of 0 0 is o, which means the king. So that's why we have to just continue it, and unless that we just have to put this dot, and we have to check if n minus 1 is 0 greater than 0 or not. And why we are doing n minus 1, as we have said, like if we have to allow the king to move for k places, we have to put k minus 1 spaces, because the place where the king is standing, actually that place is also considered as 1. So that's why we are checking n minus 1 is greater than 0 or not, and we are decrementing k. So, and up till the n minus 1 is greater than 0, we are putting empty spaces for the king to move, which is denoted by this dot. And after that we are just breaking out of this loop and we are just printing the answer. So this was a very simple logic, but if we just see the problem at first, this is a bit tricky to come up with. So that's why I have made this video. So as we can see that this got accepted. So the time complexity of this problem is n square, because n and m both are 6, both are 8 here, because it's an 8 cross 8 board. So we are just using a nested for loop, so it's order of n square. So this is how we can solve this problem called add a key from CodeChef blog channels.